and welcome to the Mathly YouTube channel. The following video was recorded by one of our staff members live at one of our contests.
I'm Taman, back again with 2 target rounds. This is your whole target 5 and 6. So we'll start with number 5. How many positive integers up to and including 2020 have the property that the sum of the squares of the digits is exactly 8? So in this question, we're analyzing digits, and the sum of the digits is exactly 8. So we need to find, or at least bound, whatever digits we're going to use to get the numbers that have that property. And so we start from 0. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. And we stop here because this doesn't work. 9 is clearly greater than 8, so we can't use 3 as a digit. So we can only use 0, 1, and 2 as the digits and find that such that the sum of the squares of the digits is exactly 8. And you can easily brute force through this, but the only way you can get the sum of the squares of the digits as 8 is when you have only two 2's that are squared. That's 8, and then any amount of zeros. So we'll start with 0 zeros. We have one possible number. That's a 2-digit number, 22. For 3-digit numbers, we have 202 and 220. For 3-digit numbers, we have for 4-digit numbers, we have 2002 and 2020. And we stop here because we include 2020. And so there are 5 numbers that satisfy this, the property that's given in the question. All right, for question 6. Let n be a positive number such that the square root of 2 minus 1 to the n power plus the square root of 2 plus 1 to the n power equals 5. Then the value of the square root of 2 minus 1 to the n power is p minus the square root of q over 2, where p and q are relatively prime positive integers. What is the value of p plus q? All right, so these aren't exactly the most fun bases we want to work with. And so we try to rewrite it in terms of square root of 2 minus 1 to the n power so that we actually get, we can solve this equation. And so what better way, since these are conjugate radicals, what better way to manipulate them than to multiply them together? We see that this is just square root of 2 squared minus 1 squared. That's 2 minus 1, which is 1. And so we see that the square root of 2 minus 1 is 1 over the square root of 2 plus 1. And taking everything to the n power, we have this relationship. Let x be this, the square root of 2 minus 1 to the n power, what we want. Then we have x plus 1 over x equals 5. You have x squared plus 1 equals 5x. X squared minus 5x plus 1 equals 0. From here, this is not factorable. So this x, we can solve for x to be negative b, which is negative 5, plus or minus negative b, negative 5 squared minus 4 by 1 over 2. So we have 5 plus or minus 25 minus 4 is 21 over 2. This is p plus minus root q over 2. So we have p equals 5, q equals 21, and p plus q equals 26. And we're done.
Hi everybody, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.